All right, hello again, pre-calculus people. So we are continuing our series on exponential functions today. In the last video, we talked about some science applications, population growth, radioactive decay, and all that good stuff like that. And today, we're going to talk about some financial applications. There's kind of some good news and bad news about this. The bad news is there's a couple of different equations. But the good news is these are kind of more kind of what I call plug and chug type things. Because the only thing we're going to be doing as far as answering questions like this are going to be plugging in a time value, seeing how much money we have after a certain amount of time, or solving for time. There's no like finding a k value like we did in the last video and stuff like that. So let's go and get into this. So again, there are two different situations. So on the top part, what I've kind of highlighted in yellow is when you have an account that's being compounded a certain number of times per year. And that's the formula. So let's talk about what those different variables mean. The A is how much you're going to have after so much time has passed. And remember, the T, the time we're talking about in these problems are always going to be in years, always in years. The P is what we call the principal. It's the same thing as the previous equation from the last video. It's just how much you start with. So if you invest, $100 in a savings account or $1,000, whatever you're putting in first and leaving there, that's what we call the principal. And then the R is the rate. It's going to be given to you in the problem as a percentage, but it is important that we write the rate as a decimal when we're writing the function. We'll talk about that in just 1 second. And then finally, the N, that's again, it's going to be given to you verbally in the question or in the problem, and it's going to be how many times it's being compounded per year. A lot of vocabulary you might see is over there on the right in that box. We don't use annually a whole lot because it's kind of boring. But you'll see quarterly pretty often and monthly fairly often. You might even see daily, but quarterly, monthly, semi-annually, those are kind of the most common ones you see. And then the other situation is when your interest might be compounded continuously. And that's where essentially you're being compounded an infinite number of times per year. And that formula, I'm not going to get into kind of the derivation of that formula. But that formula just comes out to be what I call PERT, so P-E to the R-T, okay? So let's take a look at the two situations. So the first example, so we have two people, so we got Rick and Morty, because why not? So the first situation, Rick invests $500 into an account with interest rate of 7.9% that's compounded monthly. So that's going to be my first equation, okay? So let's see what these different ones are. So he's investing 500, so that's my P. My R, again, 7.9%, but change it to a decimal. So that's going to be 0.079. Always do the decimal point twice. And then compounded monthly, 12 months a year, so N is going to be 12. So my function is going to look like A equals 500, parentheses, 0.79 over 12 to the 12 times t. Notice that n is in two different places in the equation. Okay. Now, again, only two kinds of questions we can ask here. Either how much money does he have after a certain number of years, or when will there be a certain amount of money left over? Okay. So the first one is a definite plug and chug. So we're given the 10 years. We plug in 10 for the t. 12 times 10, and you put that into your calculator. I'm not going to take the time to go back and forth to Desmos, but if you put that in your calculator, just make sure you're minding parentheses and making sure that it's looking, the calculator is doing what you want it to do. And when you do that, that's going to come out to be 1098.85. And remember, we are talking about just dollars and cents here. So we're just going to go to the second decimal place and go from there. Okay. Now the second question. So again, if you're given the time value, just plug it in and see what it spits out. For the second question, this is going to be a little bit more work to do. So we want to know how long it's going to take to get $2,500 in the account. So so that's our A value, so we want to solve for time. So I'm going to do this in a different color just so it stands out a little more. So we're going to do 2,500 equals 500 times all of that stuff. So we know how to solve that, right? So we want to isolate the exponential part. So we're going to divide both sides by 500. And in this case, that's pretty easy to simplify. So I know 2,500 divided by 500 is just 5. So I'm going to write this as 5 equals all of that. Now, look, that parentheses part, the 1 plus 0.079 over 12, that is just our base. It's a crazy base. I'm not going to bother putting that in the calculator right now. I'm going to let the calculator do the work at the end. But remember, how do you undo an exponential? We take the log. So really what I'm going to do, I'm just going to kind of make myself some more space here. So really what I'm going to do to undo this is I'm going to take the natural log of both sides. Okay? And when I do that, I can then use the log property to bring this exponent in front of the log. So what I end up having is this. So I'm going to come kind of over here just so you can kind of follow along what I'm doing. So I'm going to have ln 5 equals t times 12, and then that whole ln parentheses. Okay. Now I want you to notice this also. Important that we see this from where that t is and all of that monstrosity. Even though it looks ugly, it's just a number. So to solve for t, I can just divide both sides by that whole quantity. So my t ends up being ln 5 divided by all of that. And then again, you get your calculator, you type that in, and as I said before, being mindful of your parentheses and making sure it's looking the way it's looking. And if you do that, the answer comes out to be about 20.44 years. Okay, so if you need to pause the video and put that in the calculator, just kind of verify what that number is, that is what you should get on there. Okay, so that's a compounding interest. If it's compounding a certain number of times per year, in this case monthly, and being able to go from there. Now the other one, so our other situation is Morty has the same amount of money, he's still putting in 500 bucks, has different interest rates, but now it's being compounded continuously. So that is that one right here at the top of the screen now, A equals PE to the RT. So all this is going to be is A equals 500 E, and again, my rate is 0.071 T. That's your whole formula. 10 years, plug it in. So 500 E to the 0.071 times 10. And you put that into your calculator, you should get, it's like 1016.995, so I'm going to round that up to 1017 and no cents. We'll see what I mean there when you type it in your own calculator. And then the last question, just like before, now we want to know how long it will take to get $2,500. Same deal, right? So we take 2,500 equaling to 500 E to the 0.071 T, divide by 500, And again, we know that's going to be 5. The nice thing about this, when we take the ln of both sides, now the ln and the e, they cancel each other out. So all I'm left with is ln 5 is equal to 0.071 t. So t is going to be just ln 5 over 0.071. Easy to put that in the calculator, and that's going to be 22.67. Those are the only 2 things you have to be able to do. So if you're, you have to be able, well, I guess 3 things. Write the equation correctly, and know what situation you have. If you're compounding a number of times per year or compounding continuously. Once you have the function, we can plug in a t-value to find how much money you have after so many years. Or we can set the equation equal to a future value and see how long that will take to obtain that. As always, if you need some more help, you can talk to your teacher or send me a message or come in for tutoring. Until next time, stay safe.